about it. Now it's recording. Good, good. All right, so we're in 422. We're looking at numbers 1 through 5 with this data, okay? Now, just like what the heck are we doing again? We're going to make a scatter plot. Make a scatter plot of all this data. Then we're going to think, well, is the data set up to be linear or exponential? Do all the data points make a line, or do they make like an exponential graph? Okay. Then we're going to look at this function or that function and say, well, which one matches my data the best? Which of those two functions goes through my data, goes through the data points in the scatter plot? From that, we're going to be able to make some deductions on how long it would take for someone to go on a track that's 1.8 miles long. And then we're also going to look to see, okay, if it took a driver 0.6 minutes, how long would that track have to be? Because these are the time in minutes for different track lengths. So this is like a person that goes to different tracks, and this is how fast they go around one lap. For the track that's 1.5 miles, it takes them 0.42 minutes. Okay, so based on the data we're going to create, the function we're going to choose, we're going to be able to decide and find, based on a track that is certain length, how long it would take us, and based on how long we're driving, how long that track was. Okay, so to start, we have to make our graph, and this is the hardest part because I know nobody likes to waste paper, but you got to waste a lot of paper with this. I'm going to make my track. Well, this is going to be one part of the graph, and I'm going to make the other part this one. It's going to look something like this. Now, I look, and this is the hardest part, making the scatter plot, because look at our time. The time is always going to be on the x-axis. So the time in minutes is going to be on this axis. And look at our range of time we have. We have like 0.15 all the way up to 0.82. We don't even have like 1 minute, 5 minutes, 10 minutes. If I started labeling this, 1 minute, 2 minute, 3 minute, 4 minute, all my points would be between 0 and 1 minute. So that's not helpful. So the time in minutes, we got to go, let's go, 0.1, 0.2, 0.3, 0.4. You see how this is going to be a little bit better. We could probably even spread it out more, but this is good enough. 1.0. You see, I have to make this minutes between 0 minutes and 1 minute is right here. Okay, so that's the first step. Next step is to know that this is going to be miles. So if that's miles, we have to look and see that it goes between, what does it go between? 0.53 all the way up to 2.7. So if I go into this and I make every dash 0.1 as well, look, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.91, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.92, 0.1, 0.2, 0.3, 0.4, 0.5. That's going to get me up so I can have the 2.7 way up at the top. You see? This is the hardest part. The hardest part is even setting it up to put these points in there. Okay? But we did it. We did it. We've set it up to do number 1 now. Create a scatter plot. So I'm going to go in here. I'm going to do it as quick as I can. Let's see. 0.42. I go over to 0.42 for time, and I have to go up to 1.5. So, what's helpful for this? I do this. So I go up to 0.42. That's about here, and I have to go up to 1.5. So I'm just using this as a guide to help me find where they are. Okay. And then I'm going to go to 1.5 minutes, and I'm going to go up to 0.15 minutes. I'm going to go up to 0.53, which is about here. You see? I'm just using this as a guide so I don't have to look up and figure out where these are. 0.42, 0.42, and 1.5. That is the exact same point. Perfect. 0.43 and 1.4, so that's going to be a little bit lower. 0.82 and 2.5. This one's way up here, 2.5. See, I'm just using this to guide it, to aim. I'm just aiming. All right, 0.31 and 1. 0.31 and 1. 0.56 and 2. 0.56 and 2. 0.26, 0.26 and 0.9. And if you're just like, man, I am not doing all that. This took me about 2 minutes when I'm done. 0.15 and 0.5, okay, right here. And 0.75 and 2.7. This one's the one that's way the heck up here. All right, look. Those are our points. This is number one. Number one, scatter plot. Now let's try to remember what the heck we're doing again. What we're doing is we've made our scatter plot. Now, would a linear or an exponential function be a better estimate for this data? So this is linear. This is the line. Does that go through our points pretty well? That goes through our points pretty well, doesn't it? Okay. Remember, an exponential is where it builds slowly and then it goes up. Right? It builds slowly and then it goes up. That's not exactly what's happening here. This guy drives pretty much the same speed, and that is pretty much aligned with our points. So the question is it linear or exponential? All right, we're going to call that as L or E. Tell me in the chat, L or E, linear or exponential? Tell me in the chat. Linear or exponential? Okay, good, Devin, good, Remy. Anybody else want to take a wild guess? Good, Lizette. Wild guess if it's linear or exponential. All right, seriously, stop me right now if you're just like, I don't know what you're talking about. All right, good, there, perfect. It's linear. It's linear because look, it's a line. Linear just means line. All this data, it's not in a perfect line, but remember the best fit, the line of best fit goes through most of the data. It's the closest to all the points, right? So this isn't a line of best fit. That's a line of best non-fit, right? That's not a line of best fit. That line doesn't go through these points. That's a bad line of best fit, right? That's not a good line to go through the points. That's a pretty dang good line of best fit. It goes through most of the points. It goes, some are above, some are below, but it goes right through the region where all the points are, where all this data is located. So we are going to go with it's linear, not exponential. Yeah. All right, now this is the one where we know it's linear, so then it's just saying, okay, which linear is better then? Okay, and that's where they give us two linear equations. For number 3, they say, this is number 3, they say, okay, well, which linear is better? Y is equal to 2.3x, and y is equal to 3.3x. And the thing that a student had misunderstood this whole lesson by just one word, which is better, this or that? Or, which is better? Is it this linear equation or this linear equation? All right. Talking tough. All right. So look, we gotta see. We're gonna graph this on this line and see if it's the best fit. And also we're graphing this on this graph, see which one is the best fit. This one or this one, this one or this one. Okay. So let's do this one in green. This one's going to be the green. And the one way that you can graph, the y-intercept is 0 here because it's y equals mx plus b plus 0. But let's plug it in anyway. 0, 1. You plug in 0 here, 2.3 times 0, right? Plug in 0 here, 2.3 times 0, you get 0. So my first point is right here, 0, 0. So next, let's plug in 1. Let's plug in 1. Let's see what's happening. Y is equal to 2.3 times 1. Y is equal to 2.3. Nice. And you can actually make a point from 2 points, or you can make a line from 2 points. You can make a line from just 2 points. But we want to plug in another one just to see what's happening. Plugging in 3 points is always good, so you can catch your errors. So look, if I plug in x is equal to 20, is that going to be something I'm going to see on my graph? Here's 0, here's 1. 20 would be way over here. Even if I picked 5 to plug in, 5 isn't even going to be on this graph. It's all in relation to the actual graph you're looking at. It's not a general concept you can put everywhere. So if here's 0, here's 1, here would be 2, here would be 3. So I can't plug in anything bigger than that. I'm going to plug in 0.5. Actually, yeah, let's do 0.5. And you could choose any points to plug in. This is just making a table. You can choose any points. Pick ones that are helpful. 0 and 1, that's on the range of my x values that I made. 0.5 is halfway. I can see what's going on in the graph right around here. That's good. So y is equal to, next, y is equal to 2.3 times 0.5, which is going to be 1.15. All right. So actually, I have plenty of things to graph. I just graphed this one, right? 0, 0 is right here. Now let's graph 1, 2.3. So I go to 1, I go up to 2.3 here, right? Yep. And I go to 0.5 and I go up to 1.15, right about here. All right. So now look, those green dots I just made from these 3 points from my table, I just made these 3 points. And now I'm going to connect them and see if this looks like it's the best fit. And if I'm not satisfied, it's okay, because I have another one that I'm going to be able to graph to double check and see if maybe the other one is the better fit. Let's look at this. I just graphed the green right here. I mean, it's not a bad fit. It doesn't go through the points, but it's better than like a line that's like this. At least it shows that it's going up, that the data is going up. Okay. Let's go ahead and graph this one over here in red. Christmas. All right, we're going to graph this one in red. X, Y. Now again, I hope I don't mess up and pick the wrong numbers here. You can't mess up. There's just some that are more useful than others. Always pick 0 because it's easy to plug in. Pick 1 because it's also the edge of our data. It goes from 0 to 1. Okay. And let's see what's happening again with 0.5. All right, if you plug in 0, y is equal to 3.3 times 0, you get 0. Interesting. If you plug in 1, 3.3 times 1, you get 3.3. Interesting. You plug in y is equal to 0.5, you get half of that. Y is 1.65. Yeah. 1.65. Okay. Now I'm looking at this, and 0.33 or 3.3 is going to be hard to graph because it doesn't even go up to that. So what I'm going to do is I'm just going to graph these 2 points. I'm going to graph those 2 points. That's probably going to be enough. 0, 0. Yay. That makes sense because a track that's 0 miles long takes you 0 seconds. Excellent. 0.5 and 1.65. 0.5, so I go over to 0.5 for time, and I go up 1.65, 1.65, 1.65. Yep, right. I'm already liking this. So what I did is I graphed these 2 points here and here. The reason why I didn't graph 1 and 3.3, because here's 1. 3.3 is outside of our graph, so it's not helpful. 3.3 is like up here. It's like this. Okay. So that's fine. Hey, look, if you pick a number that goes off your graph, okay, who cares? Forget it. If you really need to find another point, you could do it. I could say, I want to see what's happening at point 2, and then plug in point 2 and get that point. Okay. You're just looking to see where this ends up being. All right, look, here are the 2 points, 0, 0, and 0.5, 1.65, so we're going to connect them. Ooh, nice. Oh, God. That looks good. Now, remember, this was an or situation. Or. So, which is better? Is it green or red? Which one is the best fit? Tell me. You have to push 2 letters. You got to put either G or R and then push return. So tell me, green or red, which is our line of best fit? Which matches our scatter plot the best? Good, 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 good. You only have 1 letter and then the enter. You got to push return or enter. That's all you got to do. All right, good, Dylan. Good, Nati. Good, Emily. Good, Jacqueline. Good, Nelson. Mandera, perfect. Isabel, perfect. Anyone else want to get a shout out for a perfect, easy question? All right. The line of best fit is red. Congratulations, red. You win nothing. You are just the line of best fit. Excellent. How do you know it's the line of best fit? Look at this line, please. Look at that red line. Oh, almost right on those points. A little above, below, perfect. A little above, below, a little bit below, a little bit above, a little bit below. But look how it goes perfectly straight through it. It's a pretty good line of best fit. Green line is below all of the points. Not a good line. You're out. Get out of here. All right, so that was number 3. Number 4, approximately how long would it take the driver to circle a track that's 1.8 miles long? Now, this is a big idea. I want you to really think about this one. The red line is now the line we're interested in. I'm going to get rid of this green line. Okay, forget you, green line. You were just a joke. You don't have to erase it, but for what I'm going to do now, it might be helpful. All right, the red line is the line of best fit. So look, I can forget about these data points now. Since I have found the line of best fit, I can make my predictions based on the line. So for instance, if I wanted to see how long it takes this guy to drive 2.2 miles on a track, what I have to do is go over to where it hits the function. This function tells me how fast it's going to go, because look what I'm going to do now. I'm going to go down. It's going to take about 0.65 minutes. To go 2.2 miles, you hit the function, go down to see how long it's going to take. Okay, let's see. How long does it take us to go 0.7 miles? We go to the function. That's how long it takes. Let's go down. It takes us 0.2 minutes. You see, a graph has all the information now in it. All this, we don't have to look. We don't have to go and say, how long does it take to go 0.7? Let's see. Well, it's closest to 0.9, so it's going to be a little bit slower. No, you go to the graph. The line of best fit is now holding all the information. So if we want to look and see approximately for number 4, approximately how long would it take a driver to circle a track that's 1.8 miles long? Here's what we do. 0.5, 1.6, 1.7, 1.8. We're here at 1.8 miles. And all I need to do is go over to where I find the function. Since the function now represents the speed and distance gone, I could then go down. It's like a multiplication table, right? And I'm going to say that it takes about 0.55 minutes. So for number 4, 0.55 minutes for 1.8 mile track. All right, number 5, last thing for the day. It takes the driver 0.6 minutes to circle a track. How long is the track? So if it takes you 0.6 minutes, minutes, 0.6 minutes is right here. So if I follow this line up, 0.6 minutes. Well, look, 0.6 minutes takes, or 0.6 minutes is for a 2-mile track, right? How long does it take you to go around a 1-mile track? It's going to take you 0.3 minutes. How long does it take you to go around a half-mile track? 0.5 miles here, half a mile. It's going to take you about 0.15 minutes or so. So for number 4, we said 0.55 minutes, but number 5, we were going the other direction. We were seeing it takes the driver 0.6 minutes to do the track. How long is the track? The track is, what do we say? 2-mile track for 0.6 minutes. Drive, I guess. Okay. Woo! That's numbers 1 through 5, guys. Woo! All right, I'm gonna let you take a screenshot. Go ahead and take a screenshot if you need. I think that's actually decently written out for you. Remember, we erased the green line. We erased the green line. All right, and then I'm gonna go ahead and stop the recording. No, I'll ask first. Give me a thumbs up, sideways, down. How do you feel about this now? This is very related to the next lesson as well. Thumbs up, sideways, down. Tell me if it's sideways. Thumbs up, sideways, down. I'll check on that, Jacqueline. All right, we got a lot of thumbs. Good. All right, I'm going to stop the video. All right.